It doesn't matter. Second slide. So I've been playing around, and in my hosting environment. Personal story is I've been using an organization called Start, SSL, to sign domain names with. And that's been great. Ed from Israel was absolutely fantastic. And then about a year ago, he seems to have sold his company to some Chinese people. And these people that bought it don't appear to be such good actors. So literally what happened about 2 weeks ago is on my Linux boxes, the intermediate certificates, etc., for Start SSL all disappeared. I had been meaning to look at Let's Encrypt for some time because I'm aware that it's a free system. And if we now have a free system for generating SSL certificates, this means that we can literally put an HTTPS certificate onto every single website. The other reason that perhaps people hadn't done this in the past is that whereas you could have many websites on a single IPv4 address for a non-encrypted site, that wasn't true for encrypted. But that changed a while ago, and now I have, I don't know, 200, 300 websites on a single IPv4, also dual stacked onto a single IPv6 address as well. And it doesn't matter if they're signed or not signed. It means also that from an interface point of view, if a person wants to sign their website, I provide a nice admin system for that and all the rest of it, that's great, but he would initially have had to go and find a unique IP address or ask me for a unique IP address first of all before it could be done. Well, that doesn't happen anymore. So I then sat down with this SSL problem and decided to try and really get Let's Encrypt working, and we'll look at a little bit of that in a second. So there's a goal there, SSL on everything, and initially I called this talk something about like safety of the internet. In many ways, we're not looking at safety, we're looking at trust of the internet. And trust, as I've learned from the beginning of this conference, is probably what people want, what the people in this room want, because if people trust the internet, then the internet will be a safe place to play in. Another very interesting thing happened on Monday. co.za got signed. DNS is available, DNS security is available for co.za. The resolvers are a little bit slow in this room, but certainly by Tuesday morning, I no longer have to use anything like the look-aside system that ISC's been running for the last while. And so this morning, in fact, I deleted all my look-aside entries. So now all my domains that have DNSSEC in the co.za domain, it's there and it works. And when you've got things like SSL, and you've got DNSSEC, then you can start doing other interesting things. And that other third interesting thing is DANE. When people come to you and talk about DNSSEC, all they do is they say that now when you ask for the name of a machine, well, humans use names, and you want to go to that website, and what the DNS does is changes that it converts effectively the name to a number, the telephone number of the machine that you're going to, if you like. And it does so in a manner that proves that the information that you get back when you ask a question in the DNS is now secure, which means the whole zone file or the information, the rest of the information about that domain name is also secure. And therefore we can put other very interesting information into our zone file, like a DANE record. So let me continue then. So just a quick brief overview, just so that you understand my environment, because this could explain a couple of other slides later on. The My VWeb system is basically built around a MySQL database. The database can be replicated in multiple locations. There are web front ends that are in multiple locations, and all they do is they interact between the user and the database so that a user can come along and he can buy domains and he can add services, and all that happens is that information is written into the database. And then there are other distributed systems in various locations which wake up every 5 minutes via cron tab, and they go into the database and they see what's changed, and they follow the instructions there, and they build to the customer to the customer's specification what he wanted. They switch things on and off, etc. So it's not real time, it waits 5 minutes. 5 minutes seems fine because the majority of people who use the system are on COSA, and COSA only actually ever updates the zone file every 15 minutes. So we're fine there. But there's room for improvement there. So let's encrypt. So it's this wonderful free certificate providing service, no costs to the hosting provider, therefore no costs need to be passed on to a customer. So this is something you can give a customer for nothing. What's also very cool is it's quite quick. I don't know the last time I tried to get a certificate for one of the main CA providers. It's a process that normally takes 2 or 3 days. It may be a bit quicker. With Let's Encrypt, if you automate it, it takes, I don't know, 30 seconds or something. So it's become so much quicker. So, as I've stated, all domains can be hosted on a single IP, dual-stacked IPv4, IPv6 address, and that's cool. So with Let's Encrypt, there's the Let's Encrypt people, they want to validate that you in fact own the infrastructure that you're trying to sign. And there's 2 ways of doing that. There's the HTTP method, where you talk to Let's Encrypt, you get a string back from them, you put it on a website in a particular location, and they effectively, you then tell them that you've done that, they browse and they see that key, and they say, yes, sure, you own that stuff, that's fine. The other one is DNS, where you take that key and you stick it into the DNS instead, and they then go and do a DNS lookup. So one can use either. I chose to use the DNS01. And I chose to use the DNS method for essentially 3 reasons. More customers run DNS with me than run websites, so I can affect more people. It's more in scope where DNSSEC's interest is in my interest, so it's the right direction. And also one of the poor features perhaps about Let's Encrypt is that it doesn't support wildcards. But it's going to support wildcards. It's going to do that in the next version of the protocol, and it's going to be doing that sometime next year. But they're going to be using the DNS method for validation. So therefore, DNS method for validation seems to make a lot of sense. So yeah, Let's Encrypt, but there's 101 different ways of using Let's Encrypt. And so the method that I chose was to use something called dehydrated. So essentially, we use dehydrated. It's a shell script, a bash script. I love bash scripts. Everyone know that the legacy system of the COSA system was written in bash? Well, that's what I did. It's a big bash script, but it was a bash script. So it does have a few downsides at the moment. I had to make it slow down because I've got my 5-minute delay on my side between when a user adds something or switches something on until it might be actually in the DNS properly. So I modified it so that it waits around until visible in the DNS. And then it copies everything properly into my existing SSL certificate management system. Otherwise, it's totally automated. A customer comes in and they flip a switch. They change it from, it used to be yes and no, do you want SSL, to yes, no, now automatic. So they switch it to automatic, and a certificate is created, done. Dehydrated has a few other issues. It runs with a lock file. It does mean that I'm limited to maybe 10,000 domains per server, but if you've got 10,000 domains on a server, then what's the problem? And I'll obviously look at other services from a Let's Encrypt in the future. So that literally has taken care of Let's Encrypt, of an SSL generation, of an SSL certificate, putting it into place. It's just a few mouse clicks away. DNSSEC on all domains, well, like I said, codes are signed now, so there's no excuse why not. So securing the zone means that that zone is trusted. You obviously know that the customer always gets the correct answer back with DNSSEC. That's kind of cool. 40% of all DNS lookups in South Africa, or 39% of all DNS lookups in South Africa, go through a DNSSEC aware resolver. That's kind of cool. We're ahead of the game there. So I've got methods of signing my zones. I run a bash script which uses bind. It's ages old and it's been working. It works. I have a very liberal KSK rollover policy. I actually run 2 keys 6 months apart because some systems are actually not the easiest thing to actually implement a key rollover. But the ZACR DNS system, or ZACR/DNS systems, run extremely well. You use EPP to update and do key rollovers. Works extremely well, no reason not to do it. And that can give you a totally automated key rollover system. So literally on my system, the customer comes in, they flip a switch, they have a choice, they can use NSEC or NSEC3. Generally speaking, they just turn on NSEC, and that's all they do. They can walk away. The system will generate everything. It will generate all the keys. It'll give it to the COSA system using EPP, and when it's time, it'll change the key, roll the key over, and update the key. And the customer does nothing. Automated completely. Just as a matter of interest, if you look at Afrinic or OpenSRS, which I also use, you have to copy the keys using a web interface, but that's not too bad. That happens once a year per domain. And that's the reason for having these huge long 6-month rollovers. So I'm currently looking at using CDS and CDNS key as well in this particular project. If you don't want to use bind, looking at not DNS that the Czechs came out with actually is very interesting because it seems to include automatic key management. And then I'm also potentially looking at Power DNS. Power DNS is kind of interesting. It looks, well, first of all, it runs totally from the database, which means I won't then necessarily have that horrible 5-minute or wait for the next 5-minute clock tick when I add stuff to my DNS for Let's Encrypt validation. And it looks like Power DNS also, their philosophy seems to be you flip a switch, that domain is signed, it does everything for you. So it can be really automated. So when you've got an SSL certificate and you've also got DNSSEC, there's a couple of other interesting things you can do, like I've mentioned, and that would be DANE. Essentially what we do is we take a fingerprint of that SSL certificate and we stick it into the DNS. The DNS is now trusted, it's secure. This means that from a website point of view, when the browser looks up the web IP address, it can also look up the TLSA certificate or the fingerprint of what the web certificate protecting the website should look like. And then when the browser goes to that website, that SSL website, it can compare the fingerprint of the certificate against the certificate, and therefore it knows it's the certificate that was intended to be put there. People seem to think SSL is secure and that there's never been any problems with SSL certificates. That's simply not true. In fact, there's a Dutch company that closed down that used to be a provider of SSL certificates. They closed down because of a problem with certificates that they were issuing. So it's not necessarily totally secure. But now we have another method of checking that certificate using the DNS. And I've got lots of other words there as well. There's a lovely little application that you can add to a browser. It's called the DNSSEC Validator, which the Czech people wrote. And that gives you a few more green padlocks and other green icons if everything is good. So that will give you a green key, for example, if the website that you go to is DNSSEC signed. And it'll also give you a green padlock if the certificate matches that the browser discovered is the same as what is mentioned in the DNS. So what you're doing here is you're building trust for the user. You're building that trust. This is not security, it's trust. And that's good. You want your users, your community people to have as much trust as possible. We can go a little bit further with this. We can, you know that we can also put SSL certificates on mail servers. And what this generally means today is if two SMTP servers are talking to each other, if the receiving machine has a certificate, then the sending machine says, hey, that's cool, right, we can set up an encrypted link. Very opportunistic, but that means then that when mail goes between SMTP servers, it's encrypted, and that's cool. But it's so easy to interfere with that and make that not work. Someone can do a man-in-the-middle attack very easily, effectively turning off that encryption passage. They intercept the mail, they can read the mail, and then they can pass it on, and no one will really ever know. But if now we have a fingerprint of the mail certificate in the DNS, when the first SMTP machine is going to do, it does an MX lookup and it knows where it's going to send it to, and then it also finds that there's a TLSA record. It not only knows that, well, if there's a TLSA record, it means that other guy I'm going to give the mail to does have a certificate. Therefore, we can definitely do a secure link. Not only that, but we know what the certificate looks like from the fingerprint. So we know that if we don't get that fingerprint when we connect, someone is mucking us around. Someone is a man-in-the-middle attack or something else, or probably the other end has got their configuration wrong. Which means we have guaranteed end-to-end email security without the end user having to do anything. Right now, what should be happening is you should be getting a TLS certificate for your mail service, so that when a client writes an email on his laptop and he posts the email up using the mail submission to his local ISP, it will be using that TLS certificate that you've now got for free, by the way. And that works fine, and everyone can do that. That's mail submission with authentication and over TLS. And that's really cool. That allows that customer, your customer, to move around to different networks because he always sends his mail from the same machine. On the far end, people use POP and IMAP, and again, in order to make that POP and IMAP work nicely over a secure circuit, that mail server needs a TLS certificate as well, an SSL certificate, a certificate from Let's Encrypt. So that's always been relatively secure. Now we've got the security running between two different SMTP servers. So we've got end-to-end encryption of a message going from a user who has no idea that this is going on to another user that has no idea that this is going on. Meanwhile, his data has been protected. ISPs in Germany have been using this as a selling point to state that their mail systems are more secure, more safe, more trustworthy than their competitors. And you can do this, and the cost is next to nothing. Just a few man-hours getting the systems into place. So that's me taking Let's Encrypt, totally automated, DNSSEC, totally available, adding a little bit of Dane into the mixture, and hopefully giving a much more secure, a much more trusted environment to our end user customers. And at the end of the day, if we don't have customers that trust us, then we don't have a business. So questions, thoughts? Thank you very much.
Hello, Jan George from Internet Society again. I have one question and one thought. So the thought is, you're using Let's Encrypt for all this stuff, and I figured out lately I've been playing in my lab with DNS over TLS, when you connect between the client and the resolver over TLS to port 853, and even there you can use Let's Encrypt. So it's useful wherever you want to put it. It just actually just works. And the question is with Dane. I've also been experimenting a lot with Dane and emails and all this stuff. When you renew the certificate, do you choose not to change the underlying key and not to change the TLSA every time, or you just keep with the default behavior of whichever client? I'm using Certbot, you're using some other, because by default they change the underlying private key and CSR, and therefore you have to change TLSA for every service you use with Let's Encrypt every time you renew. So my question is, do you keep the private key or not? Thank you.
The way I have programmed the system that I'm using is it generates a CSR once, the certificate request once, and it keeps that same certificate request. Because I'm using 301, 311 for email, then the email certificate doesn't need to change. The TLSA in for the email thing never changes. I'm still using my existing certificate management system, which means when a new certificate's been generated, there is still a conscious choice of moving to the new certificate from a web point of view, but that wouldn't be necessary from an email point of view. So it's sort of taken care of. Whether one would completely automate a web rollover, I don't know, because it would make sense, therefore, to take a snapshot, generate a new TLSA record, stick that into the DNS, wait 24 hours, and then use the new SSL certificate. But they are all based, once you created the starting certificate, the CSR, you don't need to generate a new CSR ever again.
Hi Mark, it's Nishal.
Hello.
I have a few questions for you, but they're not difficult. The first was, you mentioned something that 39% of South African DNS goes through DNSSEC resolvers. Could you cite a source, please?
Yes, it's...
I'd like to know who's sniffing my DNS and how they think they get it right.
APNIC.
Ah, okay. Right.
It's the
so it's best effort,
DNSSEC. It's
right, so it's
the
best
prof.
Effort. No, I understand that. That's fine. The second thing was less of a question and more of a point. You made lots of references to Let's Encrypt being free, and that's obviously really good to know. But I think one of the important things that you left out about Let's Encrypt is that they openly publish all the certificates that they allocate, or that they make available to people that are requesting them. And that's a really, really important thing as well. And so for those of you that are not sure why this is important, go spend time with your favorite search engine and look up MCS computing and Egypt, kind of around March 2015, I think it was, and you'll start to understand why it's actually important to know what certificates certificate authorities are handing out. If you don't get it, come and ask me and I'll tell you why the revenue model for this is completely broken. But there was just a point. My other question, and this is a fairly obvious one, I couldn't understand why you didn't do it. If you could go back a slide, please.
I'm not sure how with this thing.
It's not the green button, it's the other one.
Well, well, there's a red button, and I'm sure my slides should also fill the whole screen, but they don't. But anyway. It's a red button. You're giving me a...
The one with the slides?
Ooh,
Oh.
that's gone right to the beginning. So, tell me when to stop.
It was the last slide, I think.
Oh.
The one that had pictures on it that showed the goal that you're trying to get
okay.
to.
Yes,
So now
that
it's
one.
pretty pictures. Keep going.
Huh?
Is that it?
That is the last one.
Okay, so is this the one where you're talking about the encryption from end to end? There's one
Yes.
obvious bit that's missing there. So as a user, I can encrypt something to my mail server, but as a mail server admin, the person still has, well, I can still see what's going on there. My question to you, and I like your presentation, please don't misunderstand, I think it's good and I think it's great for folks that don't know about this. Why did you not mention PGP? Because that would be real end-to-end security, right?
That's also end-to-end security, but that's the end user actually having to consciously do something, encrypt their email before they send it to the person they're sending it to. It's also assuming the person at the far end also knows what PGP is. It's complicated. Well, it's not complicated to you, no, but this is something that you can switch on. Now, the people at both ends, they are paying their ISP money. So therefore, one would assume that they trust their ISP. And this whole scenario can help them trust their ISP. Obviously, the mail on the SMTP servers while it's stored before being forwarded is unclear. But hopefully we trust our ISPs.
Why do we trust her?
Anyway. But what we don't trust are the people. We know who our ISPs are. We have no idea what governments are looking at that traffic passing between those SMTP servers. If our packets happen to pass through the Red Sea, there's that horrible country called the UK, and they snoop at some of those cables, and they pass this data on to the Americans as well.
There are lots of countries that snoop, and they occur even before the UK. Just to be clear, I trust my ISP to deliver my packets because I pay them to do that. I don't trust them not to look inside my packets. That's the goal. And my point was really just to say that this is really good, but I think as a simple extension, maybe you'd want to bring in PHP, PG.
Yeah, you can bring in PHP to encrypt the mail. You can bring in MIME to encrypt the mail.
PGP,
no problem.
PGP.
All right, fine. Yes, Alan.
Hi, this is Alan Barrett. Following on from what Nishal said, I'm going to have to support him in a quibble about what does end-to-end mean. What you have here is hop-by-hop encryption.
All right.
From the client to the first server, it's encrypted. Then it gets decrypted. Then it gets encrypted again to go over the SMTP. Then it gets decrypted. Then it gets encrypted again to go over the POP or IMAP to the end. So that is not end-to-end encryption. That is hop-by-hop encryption. And as Nishal said, while it's sitting on those servers in the middle, it's in the clear. If it was truly end-to-end, then it would be encrypted on those servers as well.
I stand corrected. Any other questions? Thank you very much.